Okay, so let's keep going. Right? Here's another example. I know this one looks kind of scary, but bear with me. So we have this ordered pair 1, 2. Oh, excuse me, we have this relation, as you can see. And we have this ordered pair 1, 2, right? So from here, from 1, 2, we have the arrow from 1 drawing here to 2, as you can see. 1 to 2. From 1, 3, we have 1. We have the arrow drawing, see if you can see it, all the way down to 3. From 1 all the way down to 3, and you know, you keep on doing this. I mean, the other arrow 1 to 8, you can see is at the very bottom. You go from 1 all the way down to 8, and so on. 5 to 3, 6 to 2, 6 to 8. So we have this correspondence diagram. And the domain, as we can see, is 1, already listed, 5, 6, already listed. You know, again, I said already listed. We don't list something more than once in a set. For the range, it's all the y coordinates. We have 2, 3, and 8. 2, 3, and 8. 3, 2, and 8, but those are listed already. So that's what we get there. Right? Okay, now, someone have a question?
Would that be considered a function?
Well, actually, no. I was going to get to that, but
Okay.
right, this would actually, I was going to get to this, but this is not a function, right? And why? How do we know that? Well, notice 1 alone has 3 different arrows coming out of it, right? 1 would be assigned to 2, right? If this were a function, then the function would map 1 as input to 2 as output. 1 would also have 3 as output. 1 would have 8 as output. So this would not be a function. Okay? I mean, 5 wouldn't be a problem. 6 would also be a problem, right? 6 has 2 outputs as well. So this would definitely not be a function. Awesome question. Any other questions? Okay. Here's another example. Okay, so we also have, so this is another one. We have this relation, and you can see that from 1, that goes to 2. 1 also goes to 3. 5 goes to 3. 5 goes to 8. We have these wonderful arrows. 6 goes to 8. 2. So we have this relation. This also would not be a function. As you can see, we have from 1, there are 2 arrows coming out of it, meaning 1 would have 2 outputs. 1, if you put 1 into the function, you would have an output of 2 and of 3. The function, you can't have that. Same thing with 5. 5 has output 3 and 8. Well, that can't happen either. So this is not a function. It's a relation, but it's not a function. The domain, again, is all the x coordinates. So it's 1. 1's already hit. 5. 5's already in there. And 6. The range, 2, 3, 3's listed, and 8, 8's listed. Good, okay? Okay. Now, yep, here we go. So someone asked about I can't speak. Someone asked if an example was, one of the examples was a function. And the one I think that person asked about was not a function. But if you went back to this one, this relation, I think actually this is a function that we saw already. This would be a function. So certain relations give us functions, certain relations do not. So basically, from a relation, we can get a function. A relation is a function if all, I mean, I have stuff written here, but really it's if all the ordered pairs have different x coordinates. I did write that in other equivalent ways here. You know, if no two different or distinct ordered pairs have the same first component, which is the same as saying in a relation, if you have this in a relation where A, B, and C are numbers, then B has to equal to C. I mean, really what this is saying is, I'm probably making it harder than necessary, although sometimes I guess math can do that. Well, I guess I'm trying to state it mathematically, but essentially, if all the ordered pairs in the relation have different x coordinates, then it's a function. Or another way of saying that is, if the correspondence diagram is a function, you know, from any relation, you can draw a correspondence diagram. And as I mentioned, although really I should have given examples on it, but I will soon, probably next time, from any correspondence diagram, you can get a relation. So there is a connection between the two. Hence, you know, a relation's a function if the correspondence diagram is. Going back to this one, I'm back on the previous slide. You can see this was not a function. Actually, this person asked, is this a function? And this is not. And you can see there are ordered pairs here. They're not the same, but their x coordinates are the same. And when that happens, you can't have a function, mostly because you'll have something like this. You'll have a correspondence diagram that does this. Here, this was a function. All the ordered pairs here have different x coordinates. See, no, sorry, wrong button. Actually, I thought that the other example with the same output was there, but we'll see it another time. Let's see. Same thing over here. You have these two ordered pairs. They have, sorry. Oh, sorry, wrong example. Here, wrong ordered pairs, I mean. Here, these ordered pairs, they're not the same, but their x coordinates are. You have two ordered pairs with the same x coordinate and different y coordinates. Another way of saying it. So this is not a function. I don't want to go too fast, so let me do that. Okay, moving on. All right, here we go. Now, so this is a function. I mean, even without the correspondence diagram, you should be able to see that because the ordered pairs, they all have different x coordinates, as you can see. So we have a function there. And the domain is, again, 4, 9, 1. The range is all the y coordinates, 7, 2, and 10. Okay. Now, oh, good. I'm glad I have this one. This is a function. Remember, I said the x coordinates, if they're all different, then you have a function. That happens here. I mean, the y coordinates are the same. You know, the second component, that is, that's what the book also calls it, the y coordinate. Those are the same, but that's okay. So you can have different inputs give you back the same output. That's fine. That's okay. Or from the correspondence diagram, each element in the first set has one arrow coming out of it. I mean, they all have the same output, 7. That's okay. So that can happen. So notice the domain is 4, 9, 1. And notice the range is only part of y, right? Y has 7, 2, and 10 in it, but the range is only this element, 7. Well, I should say only this set. So we do have a function here. And also, again, this is showing how the range can be a part of the set y, not the entire set. Okay, this was just also another example. As you can see, this is not a function. It's not because of this part. This part's fine. It's because of this part. Or in other words, since these two ordered pairs, right, they're different, but their x coordinates are the same. You know, this is saying that 4 is assigned to 7, and 4 is also assigned to 2. So it's not a function. The domain of this relation is all the ordered pair, is all the x coordinates. So 4, 4, 9, 1. So 4 is listed once. The range is 7, 2, and 10, as you can see. Okay, let me just get the recording.